So this is question number 41 of GATE 2017 Metallurgical Engineering. Pure metal A and B form two real binary solid solutions, alpha and beta, at temperature T and pressure P. The free energy versus composition plots for both the solutions are shown below. So here free energy versus composition or mole fraction of B is given here. Now the condition for chemical equilibrium is, so options are given here where we have to define when the equilibrium between these two phases will be existing. So to know more about the free energy versus composition diagram, you can refer lecture number 6 from the course Phase Transformation in Materials by Professor Krishanu Biswas from IIT Kanpur. So now let's first understand what are the things which we can learn from this free energy versus composition diagram. So if you let's say if you are drawing a tangent to the alpha curve, alpha free energy curve, so what are these intersects which we are getting here? So these intersects are nothing but the chemical potential of, here we have a pure A end and here we have a pure B end, right? So chemical potential of A in alpha phase, and this one is chemical potential of B in alpha phase, right? Similarly, if you draw a tangent on the beta curve, so it will intersect your pure A end here and pure B end here. So here it is chemical potential of B in beta, since we are drawing on the beta free energy curve, and here it is chemical potential of A in beta, right? So in order to achieve the equilibrium, the condition for equilibrium is basically chemical potential of A in alpha must be equal to chemical potential of A in beta. So in both the phases, the chemical potential of the same species will be equal. Similarly, chemical potential of B in alpha must be equal to chemical potential of B in beta. So basically this is the condition for equilibrium. So when this condition will be achieved, so to achieve this condition you draw a common tangent which will be touching both alpha and beta curve. So in such situation we can write it here, chemical potential of A in alpha is equal to chemical potential of A in beta, and here you can write chemical potential of B in alpha equal to chemical potential of B in beta, right? So which means between these 2 points equilibrium is existing, that is alpha and beta both the phases will be existing from this point to this point, and before this point only one phase, which is alpha, is stable, and after that point, after this point, only beta is stable. So this is a two phase region and these two are basically single phase region. So these are the few things which we can determine, and using this concept only we can draw the phase diagram, because up to this composition we can say single phase region, from this to this two phase region, and from this to this, from it forms a single phase region, and this curve is basically drawn at constant temperature and pressure. It is already mentioned here in the problem. So the condition for equilibrium is this one, and the phases which will be existing at different composition is known by drawing a common tangent. So here in the option it is given in terms of activity. So activity of A in alpha, which is nothing but same as chemical potential of A in alpha. So you can replace this chemical potential with the activity. So the option which is matching with this relation is activity of A in alpha is equal to activity of A in beta, and activity of B in alpha is equal to activity of B in beta. So the right answer is option C for this problem. Thank you.